Hello, everyone. In this lesson, let's learn the function and application of AC servo driver. In this lesson, we will learn from the function overview, panel operation, hardware wiring, and parameter setting of AC servo driver. Through this lesson, I hope that everyone can correctly complete the wiring, parameter settings, panel operations of the physical inverter, complete the wiring and power-on debugging of the physical inverter, and experience the application of servo drivers and servo motors based on a case of physical inverter application. It can cultivate scientific thinking and sense of responsibility, and stimulate rigorous attitude and innovative spirit towards engineering and technical problems. Next, let's first learn the overview of servo driver functions. Function of servo driver. The servo driver is used with the servo motor to complete precise motion control and efficient drive. AC servo drivers provide precise control of motor speed, position, and torque for high-precision industrial scenarios, such as machining and robot control, ensuring stability and accuracy in equipment operation. Through parameter setting and feedback adjustment, real-time control of the motor is realized to meet the needs of different application scenarios and improve production efficiency and product quality. Adopt advanced control algorithms and power electronics technology to improve the operating efficiency of the motor, reduce energy consumption, and prolong the service life of the equipment. Support a variety of control modes, including torque control, speed control, and position control. Users can flexibly choose according to actual needs and adapt to different working environments. It has a built-in perfect fault diagnosis function, which can monitor the running status of the equipment in real time, discover and alarm abnormal conditions in time, such as overcurrent, overvoltage, overheating, etc. Provide detailed fault codes and diagnostic information to help users quickly locate problems, shorten maintenance time, and improve equipment reliability and availability. Brands of servo driver. AC servo drivers have foreign brands such as Mitsubishi and Siemens. There are also many domestic brands. Delta, Xinjia, etc. are domestic mainstream brands that have grown up. Compared with foreign brands, it is more suitable for Chinese user habits and cheaper. This case uses TSTE AC servo driver system and motor of Taiwan TECO. In terms of domestic production substitution, there is a vast market, which encourages all of you to achieve innovative results through technological innovation and domestic production substitution development. The second part, panel function operation. As shown in the figure, the TSTE AC servo driver contains 5 LED 7-segment displays, 4 operation keys, and an LED indicator, as shown in the figure. Among them, when the power indicator light green is on, it means that the device has been powered on and can operate normally. When the power is turned off, there is still surplus power in the main circuit of this device. The user must wait until the light is completely dim before disassembling or assembling the wires. Mode selection key. Mode key used to select 9 parameters. Every click will cycle in sequence. When setting data, click to return to the parameter selection image. Number increase key. Up keys select the parameters. Secondly, change the digital data, and press the up and down key at the same time to clear the abnormal alarm state. Number reduction key, down key. It is used to reduce digital data, and cooperates with the up key to achieve precise adjustment of parameters. Data setting key, enter key used for data confirmation, parameters item sequence confirmation. Moving to the left can adjust number of digits. Then finish the data setting. This operation is easy and convenient. Connection of the servo driver. Wiring diagram and terminal definition. The wiring diagram of TSTE AC servo driver clearly shows the connection mode of each terminal, including the connection position of power wire, signal wire, etc., and provides users with detailed connection guidance. The functions and connection requirements of each terminal are marked in detail in the wiring diagram to ensure that users can connect the equipment correctly and avoid equipment failure due to wiring errors. Control terminal definition. RDY. Servo is ready, indicating that the equipment is ready for operation. SUN. Servo enable, which is used to control the start and stop of the servo motor. TIC. Torque limit command input, which is used to limit the torque output of the motor and prevent overload. SIN. Analog speed command input, which is used to control the running speed of the motor. AG. Analog signal ground terminal, which is used for grounding to ensure signal stability. DICOM. DI power common terminal, which provides power for digital input signals. IG24. Plus 24V power ground terminal, providing stable power supply for the equipment. Connect to the main circuit. RST are connected to L1, L2, L3 from the transformer respectively. Provide 220V AC power to the servo motor. Ground the UVW output and connect the 3-phase 4-wire to servo motor. TPC. Connect the resistor that comes with the servo driver. Connect encoder signal line CN2. Connect CN2. Encoder signal lines have 9 wires in total. Connect according to bayonet. Connect control signal line CN1. Connect CN1. Control signal line have 24 pins in total. Connect according to bayonet. Include 1 to 24 pins. There are 2 pins from PLC. PLC control signal of X-axis servo motor. Q0.0. Pulse signal of servo motor X. Q0.2. Direction signal of servo motor X. PLC control signal of Y-axis servo motor. Q0.1. Pulse signal of servo motor Y. Q0.7. Direction signal of servo motor Y. Connection precautions. When connecting the equipment, ensure that all wiring is firm to avoid loosening and poor contact, especially the encoder connection wire between the motor and the driver. If there is poor contact, it may cause the equipment to alarm. Connect according to the requirements of the wiring diagram to ensure that the functions of each terminal are correct, so as to avoid the equipment failing to run normally due to wiring errors. Next, let's look at the parameter settings of the servo driver. Driver parameters are divided into 9 categories, including status display parameters, ON-XX, diagnosis parameters, DN-XX, abnormal alarm history parameters, AL-XX, system parameters, CN-XX, torque control parameters, TN1-XX, speed control parameters, SN2-XX, position control parameters, PN3-XX, shortcut parameters, QN4-XX, and multifunction contact rule parameters, HN5-XX. The user can cycle the parameters sequentially by pressing the mode key and select the required parameter group for setting. Parameter setting step case. Taking setting SN201 from 100 to -100 as an example, the parameter setting steps are described in detail. Turn on the power and enter the state display parameter. Press mode key 5 times to enter the speed control parameters. Keep pressing the enter key for 2 seconds to enter the setting screen of SN201. Press the enter key 4 times to shift the adjustable number of digits for 4 digits left to the highest number. Press the up key or the down key once, and the dash symbol appears. If you press it again, the dash symbol disappears. Keep pressing the enter key until set dash appears, indicating that the setting value has been saved, and then return to the parameter item sequence selection screen. Parameters to be set. DN06. Extend ON-XX series parameters and set to 1. On 617. Keep the parameter and set to H0020, CN001, Control mode selection. Set to 1, indicating speed control mode. CN00 2.0. The contact auxiliary function input contact sun function selection, and the set value is H0000, indicating that the input contact sun controls the servo start. CN00 2.1. Contact auxiliary function input contacts CCWL and CWL function selection, and the set value is H0010, indicating that the input contacts CCWL and CWL are not used to control CCW and CW drive prohibition. HN501.0, HN501.1. DI 1-pin function, set to 01, indicating that the pin action function is sun, servo start. HN501.2. Action potential of DI, 1-pin function, set to 0, indicating that when the pin is at low level, short-circuited with IG24 pin, the function acts. HN507.0, HN507.1. Do 1-pin function, set to 01, indicating that the pin action function is RDY, servo is ready. HN507.2. Action potential of do 1-pin function, set to 0, indicating that when the pin is at low level, short-circuited with IG24 pin, the function acts. Parameters table to be set. Calculation formula of servo motor rotation pulse number, where X represents the displacement, P represents the number of pulses output by the PLC, 10,000 represents the number of pulses of one rotation of the servo drive motor. PN302 represents the electronic gear ratio numerator, and PN306 represents the electronic gear ratio denominator. This formula comprehensively considers the factors such as displacement, electronic gear ratio, and the number of pulses of the motor rotation, and can accurately calculate the number of pulses required for servo motor rotation. PN302. Electronic gear ratio numerator is for adjusting the speed and position control accuracy of the motor. PN306. Electronic gear ratio denominator, which cooperates with the numerator to achieve accurate gear ratio setting. 10,000. The number of pulses of one rotation of the servo drive motor. Since the number of pulses fed back by one rotation of the servo motor encoder is 2,500, and the driver adopts quadruple frequency technology, the number of pulses of one rotation is 2,500 times 4 is equal to 10,000. Application scenarios are shown in the PPT. Let's take a look at the actual operation. This is the physical servo driver. Physical wiring of servo driver. Input main circuit, 2 pieces. Output main circuit, 4 pieces. Resistor wire, 2 pieces. CN2 wire, encoder signal line. CN1 wire, control signal line. Now let's talk about the wiring of servo drive and servo motor. A servo driver is also used here, and its brand is TCTEC. This servo driver is a TCTEC servo driver produced in Dongchuan, Taiwan, which is used with servo motor. This is the x-axis and the other is the y-axis. The wiring is connected here, but the wiring is not connected here. Next, let's talk about the servo wiring method. The upper part is the power cord, and RST is the power cord. Generally, there are 2 wires here. The following 2 wires, P and PC, are connected to 2 resistors R1 and R2 connected in series. The following is the output, which outputs 3 wires into the motor, that is, 4 wires are connected to the servo motor. This part is the signal line CN1, which is connected to a component. The lower part is CN2, which collects the encoder signal. CN3 and CN4 are basically extensions and are not used. Let's start wiring. Connect our first and the power supply is 24V. Connect here and then connect R. Next connect S. One is left empty here. The output is directly connected to you. And the resistor is connected here. Two resistors R1 and R2 are connected in series. And another connector is used here. Connect R1 on the top and R2 on the bottom. These two resistors are next to the outside. Don't make a mistake in the order, otherwise the resistance values of the resistors will be different and errors will occur. This is servo high voltage. Input servo. Here are U, V, W outputs directly connected to the servo motor. Here is three-phase 4-wire. The U of UVW is connected to U1, and do not connect it wrong here, otherwise the rotation direction of the motor will be chaotic. The sequence can be converted by arbitrarily exchanging two phases among the two phases. Finally, this yellow wire is connected to P grounding. The wire here is broken, so it needs to be soldered and connected with solder. This forms a high voltage part. After the electricity is input, it becomes a three-phase conversion, and press the S key starts the servo motor. The following part is CN1, the internal signal line. There is a discharge outlet here, and four wires are actually used, which are Q0.0, 0.2, 0.1, and 0.0. For signals from the PLC respectively. These signals have been defined and can be connected at the bayonet. The lower part is CN2, coming from the encoding line of the frequency converter, which is totally 9 lines. The encoding line comes from the frequency converter connected by the encoder, and the encoder acquisition signal line is connected here. Okay, so we get the wires connected. In fact, it is divided into three parts. One is high voltage part, the other is computer coding line, and then this is signal control line. It needs to be noted here, because we have two motors, X-axis and Y-axis, so this wire must not be connected incorrectly. If the wrong connection is made, X's may run to Y and Y will run to X, and these errors will occur. This is something that everyone should pay attention to. This is the Y-axis and this is the X-axis. There are also some control panels above. There are 8 LED display lights. default mode. Then enter key is confirm. The up and down keys can be switched up and down. Basically, this parameter is the same. After we put on the machine and adjust it, the entire parameter has already adjusted by manufacturers. Under normal circumstances, we only need to power it on. These parameters don't need to be adjusted by everyone. If you really buy a new one, you should adjust the settings in the parameter power on according to the manufacturer's instruction manual, and then meet the requirements for use. This is the wiring of the servo driver. Finally, please think about this course and complete the following exercises, aiming at consolidating the knowledge points you have learned today and further deepening your understanding. This lesson ends here. See you next time.